Good morning, all of you. In this session, I am going to explain about simple problems on design of boiler joints. Before going to the problems, first we have to know the fundamentals. Failures of a riveted joint. A rivet joint may fail in the following four ways. First one is the tearing of the plate. Here you can observe tearing of the plate at an edge of the plate. To avoid this failure, you have to provide proper margin. The distance between center of the rivet to the nearest edge of the plate is called margin. Okay, the distance between center of the rivet and nearest edge of the plate is called margin. You have to provide margin m equal to 1.5 times the diameter of the rivet. Okay, for avoiding this failure, you have to provide m equal to 1.5 into d. Second failure is a tearing of the plate across the row of rivets. You can observe when you are applying the tensile loads, the plate may fail across a row of rivets due to the tensile loads acting on the plates. Third one is the shearing of the plates, shearing of the rivets. When you are applying the loads on the plates, the rivet may fail due to shear off. You can observe here. Here the rivet failed due to shearing. Fourth failure is a crushing of the plate or a crushing of the rivets. Here this failure is crushing. These four are the important for design of the riveted joint. Now coming to the formulas, design formulas. First, for avoiding the tearing of the plate across the row of rivets, you have to provide proper tensile strength, proper tearing strength to avoid this failure. So this is the formula for tearing resistance or tearing strength. Okay, PT is the tearing strength or tearing resistance. This is the formula for tearing resistance. T minus D into T into sigma T. Sigma T is the tensile stress induced in the plate material. Okay, rivet plate material. Sigma T is the permissible tensile stress induced in the plate material. Small t is the thickness of the plate. Okay, and P is the pitch of the rivets. D is the diameter of the rivet. This is the failure of a rivet. Failure of the plates across a row of rivets. To avoid this failure, you have to provide a proper pitch. Okay, the distance between two successive rivets is called pitch. So by providing proper pitch, you can avoid this failure. Now, second failure is a failure of a rivet due to crushing. Here you can observe the resistance offered by a rivet to be crushed is known as crushing resistance or crushing strength or bearing value of the rivet. Here sigma C is the crushing stress induced in the plate material or rivet material. Okay, this is the formula for crushing strength or crushing stress, crushing resistance. Sigma C is the crushing stress, PC is the crushing strength. Okay, N is the number of rivets per pitch. Here N equal to 1 for single riveted lap joint, single riveted butt joint. N equal to 2 for double riveted lap joint, double riveted butt joint. Okay, N equal to 3 for triple riveted lap joint, triple riveted butt joint. N equal to 4 for quadruple joint. Okay, So D is the diameter of the rivet and T is the thickness of the plate. Okay, sigma C is the crushing stress induced in the plate material or rivet material. Okay. Now this is very important. This is a shearing of the rivets. Yeah, this is a lap joint. In lap joint, you can observe single shear. Okay, rivet may fail at one place. Okay, here also rivet may fail at one place. So for butt joints, butt joint, single cover butt joints, you have to consider single shear. For all type of lap joints, you have to consider single shear. But double cover butt joints, you have to consider double shear. Okay. Yeah, this is the formula for a shearing strength. Okay, when you are applying the loads on the plates, the rivet may fail due to shearing. Okay, so for determine the shearing strength of the plates, you have to use any one of this formula. For single shear, you have to use this formula. For double shear, you have to use this formula. For boiler joints, double shear, you have to consider this formula. For design of boiler joints, you have to consider this formula. Okay, here tau is the shear stress induced in the plate material. Okay, D is the diameter of the rivet, N is the number of rivets per pitch. Okay, N equal to 1 for single riveted joint, N equal to 2 for double riveted joint, N equal to 3 for triple riveted joint. Okay, here for single shear, all type of lap joints, you have to consider this formula. Okay, for single shear, for single cover butt strap joint, here you can observe these are the two plates. This one is a butt joint, this is a cover plate. For a single cover butt joints, you have to consider single shear. Okay, now here you can observe this is the butt joint, these are the two plates. For joining these two plates, we are using top and bottom cover plates. So that means double cover or double strap butt joint. For double strap butt joints, you can observe rivet may fail at two places. Okay, so here and here. So you have to consider double shear for double cover butt joints. Okay, so you have to use this formula for this joint. Okay, for these two joints, you have to use single shear. For boilers, you have to use this formula. Okay. Now, for determining the efficiency of the riveted joint, you have to use this formula. The efficiency of the joint equal to least value of tearing strength, shearing strength, and P crushing strength divided by strength of unriveted joint. That is P into T into sigma T. Here you have to consider this one as a P dash. Okay, P dash equal to P into T into sigma T. Okay, P dash is the strength of the unriveted plate. Okay. Now for design of boiler joints, for determining the thickness of the boiler shell, you have to use this formula. T equal to P into D by 2 into sigma T by 2 into sigma T into zeta L plus 1 mm corrosion elements. P is the maximum inside pressure in the cylinder or boiler. Capital D is the internal diameter of the boiler. Okay. Zeta L is the longitudinal efficiency of the joint. Sigma T is the tensile stress induced in the boiler material. Okay. By using this formula, you have to find out the value of thickness, suitable thickness of the boiler shell. For determining the diameter of the rivet, suitable diameter of the rivet, you have to use this formula. D equal to 6 root T. Here, if the thickness of the boiler shell T is greater than 8 mm, then you have to use D equal to 6 root T. For diameter of the rivet, D equal to 6 root T. you can use this formula directly when thickness of the boiler shell is greater than 8 mm. Okay. If the thickness of the boiler shell is less than 8 mm, then you have to use this formula, PS equal PC. You have to equating these two formulas. From these two formulas, you can get the value of diameter D. Okay. So already we discussed earlier, PS is the shearing strength. PC is the crushing strength. Okay. Now these are the formulas already we discussed earlier. PS is the single shear, double shear for boiler joints. You have to use these formulas for PS. PC is the crushing strength. N into D into T into sigma C. Okay. Now this table shows the standard riveted diameter and rivet hole diameter. Okay. For selecting the standard size of rivet diameter and rivet hole, you have to use this table. Now, for determining the pitch of the rivets, you have to use this formula. So this is the formula for determining the pitch of the rivets. For determining the pitch of rivets, you have to equating tearing strength of the plate and shearing strength of the plate. From these two equations, you can get the value of pitch P. Okay. From these two equations, you can get the value of suitable pitch P. For checking purpose, for determining the maximum pitch of the rivets, you have to use this formula. Maximum pitch of the joint equal P max equal to C into T into 41.28. Okay. From this relation, first you have to find out suitable pitch. Okay, P. After that, you have to check maximum pitch. P max equal to C into T plus 41.28 mm. Okay. Here capital C is the constant. Okay. From this table, you have to select capital C for a single riveted joint, for a double riveted joint, for triple riveted joint, for quarter full. Okay. For lap joints, you have to select this one, single riveted lap joint, double riveted lap joint, triple riveted lap joint, quadruple lap joint. Okay. For single riveted, single strap butt joint. For double riveted, single strap butt joint. Triple riveted, single strap butt joint. Okay. Similarly, single riveted, double strap butt joint. Double riveted, double strap butt joint. Triple riveted, double strap butt joint. Okay. So these are the values for constant C. Okay. Now these are the formulas for determining the rope pitch. The distance between two successive rows of rivets is called rope pitch or back pitch. Okay. For determining the rope pitch or back pitch of the rivets, you have to use these formulas. Okay. Now, by using these formulas, you have to find out the suitable thickness of the butt straps or cover plates. Okay. Here, margin, M is the margin. Okay. So, M equal 1.5D is the standard value for providing the margin. Okay. Now, coming to the example problems. Two plates of 10 mm thickness each are to be joined by means of a single riveted double strap butt joint. Determine the rivet diameter, rivet pitch, strap thickness, and efficiency of the plate. Take the working stress in tension and shearing as 80 megapascal and 60 megapascal respectively. Okay, from given question, first we have to identify type of joint. Here, single riveted double strap butt joint. Okay, single riveted double strap butt joint. Here you can observe this one also single riveted butt joint. This one also double riveted butt joint. Sorry, single riveted double strap butt joint. This one is a double strap butt joint. This one is a single strap, single riveted butt joint. This one is single riveted double strap butt joint. Here from the question, single riveted double strap butt joint. So you have to select this joint. Okay, you have to design this joint, double strap, single riveted double strap butt joint. Okay. Now 10 mm thickness. Here thickness of the plate, small t equal to 10 mm. Here you can observe thickness of the plates, t, small t. T2 are the straps, thickness of the butt straps. Okay. Here this one is a small t, thickness of the sheet. And here for single riveted joints, you have to consider n equal to 1. For single riveted joint, lap joint or butt joint, n equal to 1 for single riveted joint. Determine the rivet diameter, that is a small d. You have to determine small d. Rivet pitch, that is the distance between two successive rivets is called pitch. Okay, pitch P, you have to find out P. Strap thickness, here T2 are the cover plates, so strap or cover plates, T2 thickness. Okay, strap thickness is T2. And efficiency of the joint, efficiency means zeta. Okay, efficiency means zeta. Working stresses in tension, that is tensile stress, sigma T. And shearing, that means shear stress. Okay, shear stress tau equal to 60 megapascal and 80 megapascal for tensile stress, sigma T. Okay, these all are the given values. So from given question, given data is thickness of the plate 10 mm, tensile stress sigma T equal to 80 megapascal, 1 megapascal to 1 Newton per mm square. Shear stress tau equal to 60 megapascal, that is 60 Newton per mm square. And n equal to 1 for single riveted joint. For single riveted joint, you have to consider n equal to 1. Here, the given question is a double strap butt joint. Double strap. For double strap butt joints, you have to consider double shear. Okay. For double strap butt joint, you have to consider double shear. Okay. For single strap butt joint, you have to consider single shear. Okay. Here we are using double straps. Okay, to join the plates. So for double straps, you have to consider double shear. Okay, it is very important. Double shear for double strap butt joint. Okay. In first step, you have to find out a suitable diameter of the rivets. Already we know that if the thickness of the plate is greater than 8 mm, then you have to use diameter d equal to 6 root t formula. Okay. If the thickness of the plate is less than 8 mm, then you have to use PS equal to PC equation. Okay. Now from given question, the thickness of the plate is 10 mm. Okay. In our question, the given thickness is 10 mm. So that means the given plate thickness is greater than the 8 mm. So you can use this formula d equal to 6 root t for t greater than 8 mm. Okay, t is equal to 10 mm. Okay, thickness of the plate 10 mm is given. So from the diameter of the rivet equal to 18.97 mm. But from standard table, you have to select a suitable diameter, standard size of the rivet and rivet hole. Okay, so this is the standard table. From this table, you have to select a standard size of rivet and rivet hole. Here, our obtained value is 18.97. Okay, here our answer is 18.97. Here, the nearest value is 20. Okay. 20 and 18. These two are the nearest values. So here you can observe our obtained value is 18.97. Okay. So the nearest value is 18 mm and 20 mm. So you can select any one of these two values. So here I consider 18 mm. Okay. I selected this one. Okay. So I selected standard size of rivet equal to D equal to 18 mm and rivet hole equal to 19 mm. Okay. Now coming to the another step, that is a pitch of the rivets. For determining the pitch of rivets, you have to use relation PT, tearing strength equal to shearing strength. For determining the pitch of the rivets, you have to use this relation PT equal to PS. Already we know the formula for PT, that is the tearing strength. PT equal to P minus D into T into sigma T. Substitute all these values in this equation, you can get the value of equation 800 into P minus 19 newtons. This one is the equation 1. Okay. Now after that you have to use the PS formula. PS is the shearing strength. Already we know that given joint is a double strap butt joint. For double strap butt joints, you have to consider double shear. So for double shears and for boiler joints, you have to consider this formula. Okay, for boiler joints, you have to consider this formula. So n into 1.875 into pi by 4 d square into tau is the double shear for boilers. Okay, now substitute all these values in this equation. You can get value PS equal to 31,900. Okay, here n equal to 1 for single riveted joint. Okay, from equation 1 and 2, you can get the value of pitch of the rivet. So by equating equation 1 and 2, the pitch of the rivet P equal to 58.87 mm. Okay, pitch of the rivet equal to 58.87 mm. So here I consider rounded value 60 mm. Now you have to check this value for determining the check the maximum pitch of the rivets. You have to use this formula. Maximum pitch equal to C into T plus 41.28. Here T is the thickness 10 mm. Okay, capital C is the constant value. This value you have to consider from a standard table. For single riveted double strap butt joint, our given question is single riveted double strap butt joint. So the C value is 1.75. 1.75 is the capital C constant value. Okay, double strap butt joint, and here 1 is the single riveted. So 1 you have to select 1 and 1.75. Okay. So from standard table, I selected capital C equal 1.75, and this 10 mm is the thickness of the plate plus 41.28. Okay, here 58.78. Okay, that one also 60 mm nearest value. So you can select 60 mm as the maximum pitch or safe pitch. In third step, you have to design a thickness of cover plates. Here from this diagram, you can observe T2. This one is T2. T2 are the thickness of butt straps. For butt straps, you have to use this formula for determining the thickness of cover plates. T2 equal to 0.625 into T. Okay, so this is the thickness of the butt straps. And the last step is efficiency of the riveted joint. Already we know that efficiency of the joint equal least value of PT, PS and PC. Okay, PT, PS and PC. But in our question, the crushing stress is not given. So that's why I am using only PT and PS. Okay. Here, this is the answer for PT. This is the answer for PS, shearing strength and tearing strength. From these two values, you have to select least value. So 31.900 is the least value. After that, you have to find out strength of unriveted plate, P dash. P dash is the strength of the unriveted plate. P dash equal to P into T into sigma T. Okay. P is the pitch of the rivet, T is the thickness, sigma T is the tensile stress. Okay. This is the strength of the unriveted joint. So the ratio of least value of PT, PS, PC divided by P dash equal to 66.5% is the joint efficiency. This is the final answer. Okay. From these two values, you can estimate the type of failure. That means here the least value is a shearing strength. So the rivet may fail due to shearing. Okay. You can estimate the type of failure by using least value of PT, PS, PC. Now coming to the another problem. Two plates 7 mm thick. Here the thickness of the plate T equal to 7 mm. Here connected by a triple riveted lap joint. Triple riveted, that means n equal to 3. N equal to 3 for triple riveted joint. Here for lap joints, you have to consider single shear. It is a zigzag joint. Calculate the rivet diameter. Calculate rivet diameter, that is a small d. Rivet pitch, that is a P. And the distance between rows of rivets, that is back pitch, PB. And also state the mode of failure. That means you have to find out the least value of PT, PS, PC. These are the permissible stresses: tensile stress, shear stress, crushing stress. Given data is the thickness of the plate T equal 7 mm and the tensile stress equal 90 megapascal, shear stress equal 60 megapascal, crushing stress equal 120 megapascal. Okay, here n equal to 3. Okay, in first step you have to determine a suitable diameter of the rivet. From given question, the given thickness of the plate is 7 mm, that is less than the 8 mm. If the thickness of the plate is less than 8 mm, then you have to use a formula PS equal to PC. PS equal to PC relation. From this relation, we have to find out the suitable size of the diameter. Okay, this is the formula for PS, shearing strength. Here the given question is a lap joint. For lap joints, you have to consider single shear. Okay, this is the formula for single shear. N equal to 3 for triple riveted joint. Here you can observe there are 3 rows of rivets. Okay, for 3 rows, you have to consider N equal to 3. That means triple riveted lap joint. Okay, D is the diameter of the rivet, tau is the shear stress. Okay, now PS equal to 141.4 D square Newtons. Now you have to calculate PC, crushing strength, N into D into T into sigma C. N equal to 3, D equal to, you have to find out, T is the thickness 7 mm and sigma C equal to 120 megapascal. 2520 into D is the value of PC. From equation 1 and 2, you have to find out a diameter D. D equal to 17.8 mm. But from standard table, you have to select a standard size of rivet diameter and rivet hole. Okay, from this standard table, you have to select a standard size. 17. Our answer is 17.8 mm. So you have to select a nearest value. So 17.88. So the nearest value is 18 mm. The standard size is 18 mm and the standard rivet hole is 19 mm. Okay, these are the standard sizes of rivet and rivet hole. Okay, 18 mm is the rivet diameter, 19 mm is the rivet hole. Okay, now this is the formula for pitch. For determining the pitch of the rivets, you have to use relation PT equal to PS. For determining the pitch of the rivets, you have to use PT equal to PS relation. From this relation, you have to find out a suitable value of pitch. That is the distance between two successive rows of rivets. Sorry, the distance between two successive rivets. Successive rivets is called pitch. So PT, this is the formula for PT, this is the formula for PS. From these two values, you have to find out the suitable value of P. Here the pitch P equal to 100 mm. Okay. Now you have to check maximum pitch. This is the formula for maximum pitch, C into T plus 41.28. C is the constant value. This value is obtained from tabular form. Okay. For triple riveted lap joint, for lap joints, capital C equal to 3.47. Okay, our given question is triple riveted lap joint. Okay, so capital C is equal to 3.47. Okay, so from standard table, capital C equal 3.47 into thickness of the plate 7 mm plus 41.28. So this is the maximum pitch of rivet. So 66 mm is the maximum pitch here, but our answer is 100 mm. This 100 mm is greater than the maximum pitch. So don't consider this 100 mm. You have to consider maximum pitch P max. That is the safe value. 66 mm is the final maximum pitch of rivets. Okay. Now the distance between rows of rivets, that is here you can observe the distance between two successive rows of rivets is called back pitch or row pitch, PB, back pitch or row pitch, and also this one also back pitch. Now PD is the diagonal pitch. PD is the diagonal pitch. Don't consider this one. Okay. So PB is the row pitch. So this is the formula for zigzag joints. Okay. The answer is 34.5 mm is the row pitch. Now for estimate the type of failure, you have to determine PT, PS and PC values. PT is the tearing strength. Okay, PT is the tearing strength. So tearing strength P minus D into T into sigma T. Already we know the values P and D, T, sigma T. So this is the answer for tearing strength. For a single shear, in our question, for triple riveted lap joints, for lap joints, you have to consider single shear and N equal to 3 for triple riveted joint. Okay. So for single shear, you have to consider N into pi by 4 D square into tau. Okay. So this is the value of shearing strength. Now for crushing strength, this is the value, crushing strength 47,880. From these three values, you have to find out a least value of PT, PS, PC for estimate the failure. Okay, here the least value is PT. Okay, PT equal to 29,610 newtons. So The rivet joint may fail due to tearing of the plates across the row of rivets. Okay, therefore the joint will fail due to tearing of the plate across the row of rivets. Okay, now this is the another problem. Design a double riveted butt joint with two cover plates for the longitudinal seam of a boiler shell, 1.5 meters in diameter, subjected to a seam pressure of 0.95 Newton per mm square. Assume joint efficiency as 75%. Allowable tensile stress in the plate 90 megapascal, compressive stress 140 megapascal, shear stress 56 megapascal. Okay, in this question you have to design a double riveted. Double riveted means n equal to 2 for double riveted butt joint. Double riveted butt joint with two cover plates. For double cover plates, you have to consider double shear. Okay. For the longitudinal seam of a boiler shell, 1.5 meters diameter. So diameter of the boiler, inner diameter of the boiler is given, that is 1.5 meters. And the maximum inside pressure is 0.95 Newton per mm square. This is the maximum inside pressure in the boiler. Okay, assume longitudinal joint efficiency as zeta L equals 75%. And this is the tensile stress, this one is the compressive stress, this one is shear stress. Okay, so this is the given data. Diameter of the boiler shell, this is the maximum pressure. Okay, it is not a pitch, pressure. Inside pressure P equal to 0.95 Newton per mm square. Zeta L is the longitudinal joint efficiency, tensile stress, compressive stress, shearing stress. Here the given question is double riveted, double strap butt joint. Okay, this one also double riveted, double strap butt joint. This one also double riveted, double strap butt joint. But this is a chain riveted joint. This is a zigzag riveted joint. Okay. For double riveted joints, you have to consider n equal to 2. For double strap butt joints, you have to consider double shear. Okay. In our question, you have to consider two cover plates. That means double straps. Okay. For double straps, you have to consider double shear. In the first step, you have to determine suitable thickness of the boiler shell. Okay. This is the formula for thickness of the boiler shell. T equal to P into D by 2 into sigma T into zeta L. P is the maximum inside pressure in the boiler. Capital D is the internal diameter of the boiler. Sigma T is the tensile stress. Zeta L is the longitudinal joint efficiency. 1 mm is the corrosion allowance. Okay. So substitute all these values. You can get the value of thickness T. T equal to 11.6 mm. The rounded value is 12 mm. Thickness of the boiler shell is 12 mm. Here, the thickness of the boiler shell is 12 mm. That means it is greater than 8 mm. So you have to use D equal to 6 root T for determining the suitable diameter of the rivet. Okay, D equal to 6 root T. Here, the diameter of the rivet equal to 20.8 mm. From standard table, you have to select a suitable. From standard table, you have to select suitable diameter, standard size of rivet and a rivet hole. Okay, the standard size of rivet is 20 mm and rivet hole is 21 mm. In third step, you have to determine pitch of rivets, that is P. In this case, you have to use PS and PT equations. Okay, for determine the pitch of rivets, you have to use this relation. Tearing strength equal to shearing strength. You have to equating these two values. You can get the value of pitch. Okay, this is the PT value. This is the PS value. Here you have to consider double shear for boilers. Okay, this is the formula for boilers. 1.875 double shear for boilers. From these two equations, from equation 1 and 2, you can get the value of pitch. Here the pitch value is 90 mm. Okay. From standard table, you have to calculate maximum pitch of the rivets. Okay, here the maximum pitch equal to C into T plus 41.28 mm. Here the capital C, you have to select for double strap butt joints for double riveted. Here this 2 is the double riveted, 3.5 is the double strap butt joint. So capital C equal to 3.5. So you have to substitute capital C equal to 3.5 and thickness of the plate equal to 12 mm plus 41.28. So 84 mm is the maximum pitch. Okay. Now this is the row pitch or back pitch, PB. Okay, the 42 mm is the row pitch. The distance between two successive rows of rivets is called row pitch. Thickness of cover plates. For determining the thickness of the butt straps, you have to use this formula T2. Here, T, small t is the thickness of the plates. T2 are the thickness of the butt straps or cover plates. Okay, T2 equal to 0.625 into T is the formula for butt straps. So the thickness of the butt strap equal to 7.5 mm. Margin M equal to 1.5 D. This is the standard formula for determining the value of margin. Okay, for margin you have to consider 1.5 times the diameter of the rivet. Here you can observe 1.5 D, 1.5 D. These two are the margins, and this one also margin, this one also margin. Okay, the distance between center of the rivet and the nearest edge of the rivet is called margin. Okay, these are the formulas for determining the efficiency of the joint. Okay, this is the formula for efficiency. Least value of PT, PS, PC divided by strength of unriveted joint. Okay, this one is P dash. Yeah, this is the value of tearing strength. This is the value of shearing strength. For double shear, you have to consider this formula. Okay, this is the value of crushing strength. From these three values, you have to find out least value for estimate the type of failure. Here, the least value is 68,040 is the least value. That means the riveted joint may fail due to tearing of the plate across the row of rivets. Okay, the riveted joint may fail due to tearing off. Okay, now substitute PT equals 68,040 divided by P dash. P dash equal to 90,720. From this equation, you can get the value of efficiency of the joint. Here the efficiency is 75%. Okay, so this is the final answer for this problem. Okay, in next class I will explain more problems on boiler joints. Okay, thank you.